All right, question number 16. We have 6 parts. We want to match each graph with its equation without using graphing utility. So looks like the best way we want to do this is look at the vertical asymptotes. So starting with the denominator. This function has a denominator of x squared plus 1. We're going to set this equal to 0. And we're going to solve for x. So we would subtract 1. That would give us x squared equals a negative 1. And then we want to take the square root of both sides. And that will give us x equals, and we cannot take the square root of negative 1. That will give us just an imaginary 1 or an I. And so that means we don't have any vertical asymptotes on this graph. And so I'm going to look at each graph and see which one does not have a vertical asymptote. And then if there's multiple, we can plug in points and try to find which one matches. So it looks like all of these answer choices have asymptote except F. And so just based on finding the asymptote, we can conclude F would match our first equation. Okay, so now part B, we have a x squared minus 1. Okay, so I'm going to find the asymptotes for this graph. X squared minus 1. We're going to set that equal to 0. We can factor this by doing difference of squares. We can say x plus 1 and x minus 1. And then setting both of these equal to 0 will give us an x asymptote of negative 1 and x equals positive 1. So we get 2 vertical asymptotes here. So again, I'm going to look at the graphs and try to figure out which ones have a negative and a positive 1. So A and this one and D. So we have 2 options. The only other thing we can do, we can kind of look at the graph and plug in a point. So there's a difference here when we go to between negative 1 and 1. We get a negative value on this side, or we get a positive here, or we can go farther out past negative 1 and try to choose one of those values. And either I would look for a negative value because we're below the x-axis, or a positive value. So let's just go farther out and let's say negative 2. We're going to plug in a negative 2. If we get a positive value, we know A is our graph. If we get a negative value, we know B. So starting with that equation, we're going to plug in a negative 2. We're going to have a negative 2 squared minus 1. So evaluating this, we get negative 2. It's going to be a 4 minus 1, which gives us a 3. So we get a negative 2/3. The fact that we came out negative lets me know that D is the graph that will match this function. C, we have 1 over x squared minus 1. So the difference here, we had the x, and down here we don't. This is going to be almost the same, so we still have 2 vertical asymptotes of x equals 1 and negative 1. And it looks like all of these graphs are the same. So this one, we've already used this one, and the only other one that had the 2 asymptotes in this case was graph C. And again, we can plug in a point if you wanted to. We can say, let's say 2. Just plug in a positive 2. We should get a positive number. You plug in a positive 2, you get 1/3, and that looks pretty close. Okay, so when we do x over x minus 1, this would be similar to our inverse rational function. So 1 over x squared looks like this. However, it should be a little bit different because we have x over that. Our function is x minus 1 squared, x over x minus 1 squared. So this minus 1 is going to shift it to the left 1. So we're going to have a vertical asymptote at positive, no, not left 1, positive 1, right 1, sorry. We're going to go to the right 1 when we set that equal to 0 and solve it. So our graph will be centered around this line, and it'll look a little bit different because of the x on top. So we're looking for asymptote at positive 1, so that would be this graph. in this graph. So if it was just 1 over x squared minus 1, we would look at D. Our graph is going to be a little bit different, behave a little different because of the factor of x on the top. And again, you can plug in numbers and see if I plugged in like a -1, do I get a value that is negative? And if we plugged in a -1, -1 minus 1 gives us a -2. And when we square that, we get a 4, positive 4, but you have a -1 over 4 gives you a -1/4, which matches with this graph. And then we have one more, and you can just say by a process of elimination, the last graph we haven't used is the, again, reciprocal rational function, or the inverse rational function. And we have an asymptote at +1. Okay, so this is the one we just used with the x on the top. So the only other one that matches a single vertical asymptote at +1 would be graph B. And then our last one, we have our rational function, but again, it's going to behave a little bit different with the x on the top. If you focus on the asymptote, set the denominator equal to 0, we'll get x equal -1. So I'm looking for a graph with a vertical asymptote at x equals -1. So there's only one in this case, that would be E.